All right. Well, yes, thank you. Welcome everyone to my talk, Yes and Ruby's Secret Talent for Improvisation. To begin, I just want to try something together and we'll make it work virtually. I'm going to say a line and then I want you all, anyone at all, to add to it. And there's only one rule. You can respond to me by starting with yes and. So for example, I might say something like, I just made my third cup of coffee and it's only 11 a.m. And you all might say, feel free to unmute or use the chat. Anyone has a response for me?
Yes, and what about breakfast?
Amazing. Amazing. You nailed it. For many of you, might have just been a part of your very first improv scene. So congratulations, whether you wanted to or not. And you really saw right here the very number one rule of improv, which is yes and. This is a foundational principle of being an improviser, of playing with improv, and as we're going to see today, of Ruby as well. So what does yes and mean? The idea behind yes and is that you accept something that's given to you by a scene partner or within the code, and you build on that to create something new together. That's what improv is really about. It's creating something out of nothing, which might feel a lot like what you do with code, right? When you write an app, you're creating something out of absolutely nothing. Perhaps with some structure, but you really get to use your own creativity on how you get there. So a little bit about me. My name is Ifat Ribon. I live in Chicago, actually down the street from Second City right now, where I spent years learning and playing improv. By day, I work at Launchpad Lab as principal architect. We're a small digital product agency, also headquartered in Chicago, but have people all over the world now. And at Launchpad, I wear a lot of different roles. And in that, I have to improvise quite a bit on working with different people in different capacities. On top of all those roles that I play, I do still ship Ruby code and still build a lot, which is very fun for me. So for the remainder of this talk, we're going to see how Ruby isn't just a flexible language. It's probably something you all have heard a lot, and I hope something that you really love about the language, how flexible it allows you to be and all the cool and creative things you can do. And I'm going to illustrate how it's designed to actually invite collaboration, to put different pieces together in different ways. With that, I'd like to introduce our scene partners for today. So we're going to talk about blocks, procs, and lambdas. And we're going to see how each of them adhere to some of the improv rules and also how sometimes they don't really adhere to the rules. So we're going to see how they pass control, accept what's given, and play to the absurd. Let's start with passing control, or as on stage, passing the mic, so to speak. And we'll see how Ruby's blocks do that. To start, I want to share something that's true in improv, which is that only one person speaks at a time. Listening is imperative in improv because if you don't listen to what your partner's saying, it's going to be really hard for you to yes and them, to build something and ultimately make it funny. So it's imperative that one person speaks at a time so that you can clearly hear them and listen to them. The idea is that when it's your turn to respond or participate in the scene, you get to hold the stage. That's your turn in the spotlight. And then when you're done, you pass that on to your scene partner. So like a good scene partner, Ruby does this very well with blocks. I'm sure many of you all have seen blocks. They're quite popular in Ruby across a lot of code. And you've probably seen them written a few ways. This is kind of the traditional way with the do and the end keywords. So I have a method called scene, which I'll show the definition for that in a minute. And then we pass some encapsulated code within the do and end blocks. In this case, we're printing a statement. That expression in the middle there is the block that you're passing in. So we'll see kind of what this does. This is the other way to write blocks. I'm sure a lot of you probably use this notation as well with the curly braces, but we still have our scene method and we have our block and the expression within it. So let's see what this does when we run this code. First, we'll see that first statement we saw on the previous slide. That's the method statement. Then it's going to pass it off to the block who's going to enter the conversation. with its own expression that you want to evaluate. And finally, it'll come back to the rest of the block to continue the scene. And this is exactly how I think about blocks in Ruby, is like a conversation back and forth. You do some work, you pass it off, and you finish the rest of your work. So how is Ruby doing this? Ruby is doing this with the yield keyword, which you can see in the middle here. So again, we saw kind of the statement that we want to do in our method. So that first put statement, pass it off, and then we'll come back. This is how yield is using Ruby to pass the mic. Now, I do want to point out that you can call yield as many times as you want, and it will always only use the block that you gave it. So in this case, you might imagine that we would kind of repeat that expression that we saw here twice. This might be useful if you want to use different arguments, say you're formatting different things, or you want to play with configurations. That's where calling yield multiple times could be useful. I wouldn't say it's the most common thing, but what I really want to show is that in contrast, you unfortunately can only pass one block at a time. That is, a block only gets the chance to give you one idea back. If you try to pass a block again, and here I'm just kind of using both notations, what you'll see in Ruby when you try to evaluate this is a syntax error. And that specific syntax error is that there's an unexpected brace there. You could imagine it's a do there, and it would tell me that was unexpected. Unexpected end of input. The method didn't expect to receive more than one block. So I'll note that for a minute, that you can only pass one block at a time. Now, the other thing that we saw is that blocks are anonymous. That's right. We didn't give it a name. We didn't store it in a variable or anything like that. And that's by design. However, if you wanted to name that scene partner of yours, you could do that. And the way that you do that is by introducing the ampersand operator. What I want to call out here is that we have the same scene method that we had before, but I actually want to name and capture that block, a block or a piece of code that we want to pass in. And we do that with that pink ampersand. When you go ahead and want to evaluate the block that you passed in, instead of using yield, you'll use call. What's actually happening behind the scenes, so to speak, is that that ampersand operator is converting the block into a proc, which we're going to see later. To this end, this method will evaluate the exact same way as we saw previously. However, what if I want to introduce multiple scene partners this way? Say I want to pass multiple blocks in again, like we tried to do before with this notation. Great, I name them, I'm going to pass them in, and we're going to run, right? Not so much. We're going to get a syntax error again. So once again, Ruby's design is illustrating that for blocks, we're only get to pass in one at a time. By this nature, blocks are meant to be ephemeral. That's by design. You're not really meant to reuse them or pass them around several times. There are other structures that Ruby offers you for that. So blocks are much more like game scene partners, where you hit the game in improv and you move on to the next one. So that's a little bit about blocks. Is there anything you remember about blocks? That you can use them with one method at a time, really any method at all. You can pass one block at a time, and you can think of that as like one mic that Ruby's passing around. So with that, we saw some pretty simple examples with some print statements about blocks, and perhaps that's quite familiar to all of you. So now I want to talk a little bit about what happens when you start to introduce arguments. And we'll talk about how these special Ruby functions work on accepting the offer in the way that they handle arity, which is the number of arguments that they can work with or define. So again, a little bit about improvisation and how improv thinks about this. One of the core principles that is a fast follow to yes and is that you never deny the premise, right? You never want to say no, but, unless you really know how to get the right laugh. You never deny the premise. You want to take what your partner's given you and build on it. That being said, you don't necessarily have to take everything that your partner gave you, right? You can pick and choose what you want to work with. But you accept what they offer and you continue the scene. So let's revisit blocks for a minute, since we just talked about those. So here's an example about how you might pass an argument into a block. If you're using the yield keyword, you can pass arguments directly to it, much like you would to a method. That argument could be coming in from the method signature. It could be something hard-coded. I'm kind of showing two examples here. When you go to use the block, you can indicate how many arguments the block itself accepts. And this was a pretty key distinction for me to learn, was that word offer in the pipes in the lower example with the block is just a stand-in variable, much like a method argument. So you can see that the C method is going to pass prop to yield. Block happens to call it offer, and that's all right. It'll accept it. But what's more interesting than that is that in the top example here, we are trying to pass in two arguments to yield, both the prop that we received from the method as well as something else. However, when we actually went to pass a block to the method, we only indicated that it wanted to use one thing, the offer. So the expression you'll get out is just using the one thing. That's a really nice thing about blocks is they don't complain. They'll accept what you give it and move right along. The cool thing is this works in the opposite direction as well. So let's say we only pass the one argument in, and I want to define a block that does take two arguments, including that context. The yield, happy as a clam, I'm going to take it and move along. What it's really going to do under the hood is it's just going to assign nil to whatever arguments it doesn't receive. In this expression, we won't get an error. Obviously, if you were trying to do something with that second argument that nil doesn't respond to, you would get an error, but it would be about the fact that you're doing something with nil and nothing to do with the block itself, caring about those arguments. So this is really helpful and really comes to in play when you think about extensibility of code. So a lot of times you'll see in gems and things like that, they will offer you to set up an initializer where you yield a config object. Well, over time, as that gem evolves, they might want to introduce other parameters or other contexts. And by using something like a block, who is flexible with arguments, it's really easy to make that gem backwards compatible for people who haven't upgraded to the new paradigm of new arguments. So you can see how this could be this could be very valuable, this idea of being flexible with arguments. So this is probably a good time to bring out our other two scene partners, the proc and the lambda. And I'm going to show how they differ. I think this is something a lot of people are like, oh, I know what a proc and a lambda is, but I can never keep them straight. Hopefully this helps a little bit with that. The way that I think about them is that the proc is more of the loose improviser. The proc likes to heighten, likes to play fast and loose, and we'll see how sometimes that might ruin the scene. The lambda, on the other hand, is more by the book player. It does really well with structure and plays well in that way, but as soon as you try to deviate, it's not going to be so happy. Let's talk about the proc first. So a proc in Ruby is an instance of the proc class, which is why you can instantiate a new proc by calling proc.new. Or as we'll see, Ruby does offer a shorthand, which is the already instantiated version, lowercase proc, which you might have also seen. And we'll see in examples next. What you'll probably also notice is that this looks a lot like a block. And that's kind of all a proc is a proc is a class, it's a first class object in Ruby that encapsulates a block. That's its entire class definition, instance definition, I should say. It looks and reads a lot like blocks in that you can pass arguments in the pipes and you can do what you want with those arguments. Again, procs behave a lot like how you might expect blocks to behave in that they're flexible with those arguments. In this slightly smaller example, you can imagine it looks a lot like our previous example where we only pass one argument into our actual proc expression, and the proc will happily express that. As we saw before, and I alluded to before, procs are called with the call method. There are other fun ways to call them, but the call method is the most conventional one that you'll see out there in the wild. Again, this kind of ties back to what we saw with the ampersand and why I was saying that the ampersand is converting a block into a proc. It's encapsulating it in this object, and that's why you would use call. The powerful thing about procs, and we'll see with lambdas as well, is that you can store them in in variables, and you can pass those around as arguments. Unlike the example we saw before, where we could only pass two blocks with we could not pass two blocks with the ampersand, we could pass as many procs as we want to. So I could have, maybe there's another proc here called fast, and it expresses something else. I could call my scene method with fast and loose, but without the ampersand. And Ruby wouldn't complain. So let's talk about how lambdas are a little bit different from that. A lambda is actually an instance of the proc class with some special flags and behavior about it. The way you can define a lambda, like many things in Ruby, there are multiple ways to do it. You could use the lambda keyword here, but the more conventional one right now is to use what's called the stabby lambda, which is this arrow operator we're seeing here. If you were to use the lambda keyword, it would look a lot like this with the arguments in the pipes. The interesting thing is with the stabby lambda, you do actually put the arguments outside, and they kind of look a lot more like a method. And that's a good way to remember that because lambdas also act a lot more like methods. Lambdas act more like methods because they are very strict about their arguments. If you do not pass in the right number of arguments, you will get an argument error, much like you would with a method. Again, lambdas, because they're just procs, are also called with call. So those look a lot alike. So why wouldn't you want to just use a method then if lambdas look a lot like that? So for maybe a very simple example, we could write a method called perform that takes a character and a scene, and it does some things with those arguments. If we wanted to repeat something with my character, I would have to call perform and pass in my character every time, as well as the scene that I want them to be in. With a lambda, you just have to pass it in once because lambdas, procs, and blocks, the special thing about them is that they are closures and encapsulate the scope that they were given, the context of the scope within they were given. So in this case, I'm still using a method, but you can think of this method as a mini factory. The method itself might take character, and I can kind of establish a character, my man in black. The lambda itself is then going to take in different scenes and put that character into different scenes. So it looks pretty similar, but when you go to use these things, first, I instantiate my character, my Dread Pirate Roberts, with the man in black, and then I can send him along into any scene I want. So in this case, we only have to call the different scenes, and the lambda remembers that we already established the man in black as the character. So this can also be quite powerful to kind of pass around bits of reusable code where something is the same. One thing is the same, you want to establish that once, and another thing changes over time. So let's talk about when things get a little bit weird with these two players. We talked a little bit about the idea of the lexical scope and the context in which these functions are created. And we showed a little bit about how they manage control flow so far in terms of passing the mic. Well, let's see what happens when we try to mix the two. One thing to know about improv when you're on stage is the idea of sweeping a scene. Sweeping a scene is when you end a scene. And the cool thing about being on stage in improv with one partner or many partners or even people off stage waiting to be in the next scene is anyone gets to sweep at any time. You could be in the scene, you could be like, we're done, we hit the high note, we got the big laugh, let's kill it. Or you could be off stage and be like, ooh, I want to turn, let me get in there. So the idea in improv is much like everything that's unexpected, so is the end of the scene. The lights go down, whether you're ready or not. Let's see how our two-letter functions work with this. So a lambda, in this case, we're going to define a lambda inside the method, and we're going to put a return. I realize this is a fairly simple example, but the idea here is that there is an explicit return in this lambda. The scene is going to give some context, our first statement. The lambda is going to do some work. We're going to call it with call, and then the scene is going to do some more work. When you do this with a lambda, let's see what happens. First, the scene offers up its part of the method. Then the lambda responds with what we saw before in the definition, and the scene continues. We reach the end of our scene. Okay, well, let's see how procs do that. So pretty much the same method, except for we are going to define a proc in the middle. Like I mentioned, that lowercase p proc, just an instance of the proc class, is going to look all the same. So let's see how it plays with this scene. Here's the first offer. That's amazing. It responds, which is great. And it just swept the entire scene, actually. We are never going to hit that last statement in our method because a proc will just sweep the whole scene and kill it. What I want to say here is that the proc is going to exit the method and we just get an easy nil. No issues there. But what happens if we do try to define the proc outside of the method, somewhere else in our app context? If we try to call that exact same method here, right? The method will start something. We'll try to call our proc. The scene will try to continue. We'll offer up our first gift. The proc will try to respond, and then it's going to try to sweep. But the problem here is that there's nothing to sweep to. It's like you weren't even in the stage, right? And this has to do with the proc's lexical scope. In our example here, there was no encapsulating scope around this proc. It's just kind of hanging out in our app somewhere. As far as the method is concerned. So when the proc is called and it attempts to return, it's actually just going to exit out of everything. I have definitely run into this before, this local jump error, and I've never fully understood it, but understanding these differences between what a proc considers its lexical scope and how a lambda handles it helps me understand it a lot better. So if you take nothing else away from this little section, it can be that the difference between lambdas and procs in terms of their returns, a lambda says, I'm done, and allows the scene to continue. A proc says, we're done, and the scene is killed. All right, so we covered a lot of ground today. Just to do a little callback here, we talked a lot about Ruby's different functions that you can use to have a bit of a conversation, the way that they hold focus and then pass it off, and they share the stage with the method and other pieces of code you might want to use. We talked about arity and argument flexibility, about accepting what's given and deciding what to do with it. And finally, understanding when to return with intention. If you want to continue the scene, use a lambda. If you're trying to exit the scene for whatever reason early, a proc could be a really good fit. So all to say, this is how Ruby is designed with intention to listen, accept the offer, and say yes and. Thank you very much. Tickets are $5 at the door.